This is the LotBot Robotic Arm. When the robotic arm is first turned on, or the initial position action is selected from its controller, it goes to a 0 or home position for the base, which is controlled by a stepper motor and a limit switch. The rest of the arm uses the other servos to make sure that they're still working. This first demo shows the robotic arm moving an uncooked egg to a pad, then picking it up and moving it to another pad. The arm is then moved away and returned to pick up the egg and return it to its initial pad. The actual placement of the egg is not important, but the fact that the fragile egg can be moved with a robotic arm is the object of this project. This demo shows the robotic arm exchanging the position of 2 uncooked eggs. I've marked one of the eggs so that you make it easier to follow the exchange of the eggs. You cannot see the selections on my Raspberry Pi based controller screen during these first few demos, but I will be showing you the screen in more details later in this video. The actual code and controller components that I built have been discussed in another video, and that video is called LotBot Quadrupod and Hexapod Robot Controller. This demo is a repeat of the last demo, but is done twice so that the location of the eggs at the end of the second exchange will find the eggs where they were at the start of the demo. It's really a demo to show that the eggs can be moved around quite a bit and not break. There are 3 videos discussing the robotic arm, and you are seeing one of them. This is part 1, the demos. Part 2 video discusses the components and how they are connected, the wiring and different pins that are being used on the different components. Part 3 describes the code in detail. Most of the robotic arm has been printed. Use a 3D printer, the structure of the arm will be completely discussed in part 2. But I do want to mention that the black grabbers and the pads where the eggs are placed were printed with a soft TPU filament, and this eases the pressure on the eggs. Well, just to show you that these are really uncooked eggs, I'll break this one, and there's the yolk, and the other one. Well, this one's a little harder. Well, it did break, but anyway, I did use uncooked eggs, and now I'm going to put them away in the refrigerator for tomorrow morning's breakfast. During my development and testing, I use 3D look-alike eggs instead of chicken eggs. With all the bugs that you get in developing code, I didn't want to break them all over everything. I'm going to continue in the rest of any demos for this video. I'm going to be using the 3D look-alike printed eggs. When the robotic arm is turned on, its display provides startup and connection information. The robotic arm uses an Arduino computer that supports Wi-Fi to process commands it receives. These commands can be entered on a serial window that is connected to the Arduino IDE in a PC or an iMac. They can also be sent by the controller that was identified during the initial demos. The controller is a Raspberry Pi that has been set up as a Wi-Fi access point and sends messages that are created from selections on displayed Node-RED user interfaces. I use MQTT server to send these messages. These topics are covered in Part 2 components, Part 3 code videos, as well as the controller video that I previously mentioned. If there is no serial display and no Wi-Fi controller, the robotic arm will perform its homing routine and show the demo exchanging the two eggs. In order to send commands to the robotic arm, you either need to be able to enter them in a serial monitor or the controller. If the robotic arm is connected to a PC or iMac running the Arduino IDE, which is this window that's sort of bluish, you can select this button right here, and that'll bring up this serial window, and commands can be put in right here. Well, I'm trying to hold the camera and show you this information, so the picture may wobble a little. But anyway, this are the selections. These are the Node-RED user interfaces, and you've seen the initial position, which is the what the robotic arm does when it first comes up. You've seen the demo 1, the demo 2, and the demo 3 was just 2 times of the demo 2. The next line here, it has some things where it can move left or move right. That's basically the stepper motor, which controls the bottom. You can add 1 step to it. You can 5 steps or 10 steps, or you can, that's the current position. You can subtract 1 step or 5 steps or 10 steps. This way you can find out exactly where you need to put the robotic arm to pick up something or to drop something off. These two selections will allow you to open and close the grabber, or you can change the degrees that the grabber opens, and you can subtract the degrees. Then the bottom servo, you can control it in degrees, and you can control the next servo in degrees. Now let me just identify which of these servos is what I call 1 and 2. This first servo right here on the bottom, well, the stepper, of course, the stepper motor's inside this box, but this is what I call servo 1. This is what I call servo 2, and then the grabber servo is in this box right here, and it controls this gear, which allows the grabber to open and close. So what I like to do is just come over here, and there's a move left. So I'm just going to select the move left, and you can see it moved to the robotics arm's left, not your left. And then if I go back to selecting center here, I'm going to select center, and you'll see that it goes back to the center. I'm going to move the arm to the right. Okay, so now the arm's moved to the right, and what I'd like to do is move the the second servo up, so you can see the top part of the arm move by moving it 10 degrees. Now I'm going to hit this 10 degree and you'll see that it moves 10 degrees. That way if I move another 10 degrees, I can move another 10 degrees, or I can come back and I can go, instead of adding 10 degrees, I can subtract 10 degrees. I'm using this, it's hard to see both of them at the same time, but I'm going to be subtracting 10 degrees so it comes back to its starting spot. And then I'll just go back to the center on the base, which is right here, and it'll go back to its initial position. Okay, now you'll see in the code that each of these selections sends a 3-character code to the robotic arm. That's the same code you would key in if you were using the serial monitor. The other thing I wanted to show you is before, when I showed you the screen, I showed you that there was no serial monitor, there was no network, there was no MQTT server. And but now you can see that I have both the capabilities of being able to enter commands on either one. One final thing that I'd like to discuss is that when you hook up the actual servos to the equipment, you never know exactly what angle you're hooking a piece of equipment to the servos unless you take a lot of time and just come up with where the 0 position is. I just hooked mine up sort of randomly as long as I was within the range of the degrees that the motor would move. And by moving it a certain number of degrees, I was able to get the position that I want, whether the robotic arm is straight up or whether it's bent or whether the top part is bent or whether the grabber is open or closed. However, in order to do that, this display down here, I'm able to change the display to see the degrees that the motor, or rather the servos, are at, and equate that with the physical layout of the way the arm is. So in order to do that, I have a selection over here that displays the position information. So I'm going to select that, and you'll see that the screen changes to this. And what this is saying that at this position, I have the stepper set to a 0 position. Servo 1 is at 118 degrees as far as the servo is concerned, but as far as the position that I see it at a more of a 90-degree angle with respect to the surface. And if I look at the servo 2 straight up, so evidently I've got servo 2 exactly, and the grabber is sitting at that's 187 degrees. So you know, it may not look like 187 degrees if you look at it, but that's the way the servo is, and I've equated the positions that I want with these different degrees. So I can see what's happening. So if I go to and if I go and move the stepper, you see right now the stepper is at 0 position. If I move left, and see, it now becomes minus 50. And if I move right, it now becomes plus 50. So I can move the servos and the stepper, and I can see exactly what the reading is, and I can equate that to the physical position. Anyway, that's really all else I have to tell you about the robotic arm. I have part 2, which is the components. So I open up the bottom of the of this base, and I show you the components. And then in part 3, I go through the code that's in the Arduino that's in this box, and I go through it line by line.